everyone. Good evening, everyone. So we are going to start today's lecture regarding to the CAP theorem, which is the kind of a theoretical background of the NoSQL database. So to understand the CAP theorem, so I think that I'm going to review some transaction management that we discussed in the advanced database course a long time before. So then we are going to touch what is the requirement of the distributed system, then what is the CAP theorem, then how NoSQL database address that. Okay, so before we start today's lecture, I'd like to remind the project. Let me change the screen. So this is the homepage of the Canvas. So during the phase 1 of the test 1, the test 1, the part 1, all students submit selected the NoSQL database. So if any wrong information or the missing information, please let me know. I'm going to update it. So in the next the page, so you are going to research on this selected database, then present in the classroom. So by the due date is the Friday, but you are able to submit the revised one by the Monday next week. So before we have the class for next week, so October 5th is the form deadline to submit your phase 2. In this phase 2, you need to submit your research, the paper, and then you are going to present what is the ABC database and what is the characteristic and what is the target modeling and what are the shortcomings and how we can use such a database, such as the API level or the program level and so on. So you are going to present your selected database. So in the next class, each student will prepare the less than 5 minute presentation based on your presentation file, so using Zoom. So if you are not available online, so you can, when you submit your phase 2, you can submit your recorded video, then I can turn on during the classroom. If you do not submit your recorded video, but also you do not show up in the Zoom meeting, you will be automatically the 0 mark for the presentation part. So please prepare your 5-minute presentation, less than 5 minutes. So because we have the 13 students, so it may take roughly an hour. So if you have the longer than 5 minutes, so it will be easily the 1.5 or 2 hours. So please prepare 5-minute presentation. At that time, I'm going to give I think all students can share the screen. So you guys can share your screen and present your selected database, your research on your selected database. Okay. So any question regarding to the next week presentation and project? You can unmute. So if you have any question, or you can use a chatting box if you have any question. I strongly suggest to use IEEE the paper format. Research should be format the paper format. So it's for your practice. Please use IEEE the 2-column format. It's for your practice, for technical writing. Any other questions? Okay, great. So we are going to start today's lecture. Oh, by the way, one more thing is please be familiar with the Zoom function. I heard that nowadays most of the interview do the online using Zoom a lot, or the other tool, but the Zoom is most popular one. So for your technical interview or instead of on-site interviews, Zoom is most popular media for the communication. So it is important when you graduate, and also I'm not sure, but probably this kind of pandemic situation will last at least a year. So when you search a job and when you have opportunity for interviews, so you should be familiar with such the Zoom meeting or the Skype meeting, and also presentation. So please be familiar. This is kind of practice for you guys. Okay, and then let me change it. Yeah, still it's not easy for me to use the different function and share the screen and so on. Okay, so I think that you are able to see my whiteboard, and we'll just start today's lecture to review the database. So in your database class, advanced database design or database design, we mostly learned how to design the relational database. So which means how to use the relational database model for the information that fit to the relational database. Then the plus, so I introduced several database technology, including the query processing and the query optimization. Both of them are used for the efficient query. So for example, when we access the data in our relational database system, there are many different ways to access the table. So I use the example of visiting the city. So when you visit the city, so you can take a walk, or for sightseeing, you can rent a car for driving, and also you can rent so for example, chopper or helicopter, or even the private guide. So there are a bunch of different ways. So similarly, when you access the table, there are many different ways, like the sequential search and using binary search, and also using the index and so on. So let's say that we have the 3 different ways to access a table. There's another table, 3 different ways. Total 9 different ways to access the 2 table. Then when we join the 2 table, there are different types of join. So for example, the nested loop join is too small. Nested loop join, and sort merge, and hash join. There are different types of join. So for example, when you travel to city, so you can connect the 2 city by train, or by driving, by airplane, and so on. Let's say the 3 different ways. Okay, so total, so 9 times 3 already, it's 27. Also, you can visit this A city first, then followed by B, or the B followed by A. So you have the 2 different. So already 57 different ways. Among them, we try to select the fastest way, because one of the main purpose of using database is to access the data, retrieve the data fast. That is our main purpose. So to do that, we are going to select the one fastest way from the many different ways. That is the purpose of query processing and query optimization. And also, we learned about the backup and recovery. Another important the reason why we are using the database system nowadays is we try to keep the data securely, safely. In case of think about the 9/11. So nobody expect the entire the center will be gone. Such a thing happen. So after that, the disaster recovery, backup and recovery is getting more important. Backup and recovery. And also database, the DBMS, database management system, DBMS system also include the what? The language interface, like the SQL. SQL interpreter is a part of that. Then this one is connected to this. And also, as I mentioned the last time, one of the ways to speed up the database query is using cache. So in other words, buffer. So buffer management is also the very important. So each DBMS system has their own component to manage the buffer. How to manage the query. Most popular approach is LRU algorithm, least recently used. This LRU is very popular for any cache management. We can actually have the kind of linked list, but this recently used one is over here, and the least used one here, so this one will be selected again. This is the idea of LRU algorithm, like that. And many more components that actually form a DBMS system. Another important one is the transaction management. So what is the transaction management? So transaction management actually starts from the operating system. In your operating system class, you learned about the race condition. So what is a race condition? Race condition will be happen when you access the shared data. Shared data by what? To consumer. Okay? If there are two consumers, like the CPU 1, CPU 0, you have the two CPU. Each CPU run the process. So you have a process 1, process 0. So when two separate processes are accessing the same data, shared data, memory, this one will be happen a lot nowadays. All right? Think about the processor on your laptop or the computer is a quad core, the dual core. Nowadays, even the cell phone is the dual core or the quad core. So which means the multi-threaded. At the same time, the multiple threaded will be processed, but they are accessing the same memory. It's a shared data. So for example, if the shared data is A is 1 currently in the memory, this CPU 0 always increment plus the A by 1. If why? The process 1 is always A minus 1. Always decrement the value. Then if we run the two processes at the same time for each CPU, what will be the final output of A? So this is called the race condition. This can be what? 1 plus 1, so it may be 2. Minus 1, it can be 0. Also, plus 1, minus 1, it may be 1. We cannot guarantee the output. So this is called the race condition. So this race condition will be happen when multiple processes can access the shared data. Then race condition will happen. Then how can we address such a thing? How can we guarantee? So we defined this kind of problem as synchronization problem. So synchronization problem is not only for the operating system, it's any computer system, application level, operating system level, even hardware level, network level, it happens always a synchronization. We need to guarantee the output. So how can we guarantee the output? How can we synchronize such a data? So in operating system, we learned about critical section solution. So we are going to define when this process program access the shared data, we define that part as a critical section. Then basically critical section use what? Lock. Getting the lock and release the lock. So operating system provides such a programming mechanism. Whenever process access enter the critical section, then decide. So there are requirements. Let me start here. This will be on the couple of hours, couple of weeks, the discussion, the critical section. But basically overall to solve the problem, so critical section, think about I think that if you took the operating system class, I have used the example of going to bathroom. So bathroom is a critical section, okay? You don't want to share the bathroom, right? So how can you get into the bathroom if nobody is waiting? So you can get the lock, okay, key and the lock, and use it and release it. But if many students are waiting outside the bathroom, we need to do something like the first compressor or the vote. It's really urgent, so that use it and like that. Then we can solve such a critical section problem, synchronization problem. Then one of the solution, there are many solutions. It's an application level solution and the operating system level solution, even hardware level solution. Hardware level solution use instruction. So which means even CPU provides certain instruction to address this one. But we learned about the database encounter same problem. So database, think about the database, the operation. What are the basic operation of the database? Basically, read the data and write the data. Two operation for the certain item. Read data and write the data. Read data is not a problem, right? You can read whenever you want. No matter how many the database processes are working, so you can read anytime. However, when you write the data, that causes the problem of the synchronization because they are accessing the shared data. Okay. So specifically, database. How does the database solve the problem of the synchronization? Anyone remember? At that time, we learned about the transaction. So transaction management is also critical, very important in database system because database itself allow many users, many processes, the transaction, right? So they always share the data, If database allow only single user, we don't have to worry about this. We don't need such a thing. However, most of all the database system allow, not all, most of them allow the multiple user to access the shared data. So that causes the synchronization issue. How do they solve the problem? We learned, so database use transaction concept. It's not only for the database, but the database mostly use transaction to solve the synchronization issue. Then, what is the transaction? Then, so what is a transaction? So transaction is a set of operations. Operation means read or write. It's a set of operation. It's a what kind of operation? It's a atomic operation. Atomic operation means once the one transaction may include many read, write, and read, write. But all of these transactions should be done all or nothing. So this should be done all or nothing. Which means, in case something happened in the middle of the transaction, database transaction is terminated. Firstly, it should go back. So any write before this one will not be applied. The applied event is once you complete everything, then all change will be applied. So because it's atomic, so this is called the transaction. So actually we use a lot the name of transaction. So my banking transaction is very slow. Something weird transaction happened. It's a fraud or scam transaction. At that time, what is a transaction? Actually, that transaction is a logical concept. That transaction has a lot of operation. So, for example, if you transfer the money to your parents, okay, from your account to parents' account, that is one transaction, transfer transaction. So transfer transaction. That includes what? Read your balance. Read. Right? And read your parent balance. And write your balance take out. And write on the parent. So many read and write will be. But this is all or nothing. It's logically one atomic operation. Okay? So if something happened in the middle, so my money was taken out, but my parents didn't receive the money yet. At that time, it should be revoked. Go back. So this is the transaction. Then, how can we implement such a transaction in the database? That's the reason we learned about the transaction state. So we can start the transaction. Start transaction. Sometimes begin. Begin is more popular. So begin transaction. Then end transaction. Always the transaction start with the begin transaction. Always end with end transaction. So this is the group of transactions. In between, you can put a number of the read, a number of write. But they will be always end with either commit or the rollback. No, avert. So your transaction always will end with commit or avert. Commit means it's a successfully done, so apply everything. Avert means it's a falsely stop. In case of a falsely stop, you need to roll back. Roll back to the beginning. So any change in between until the avert will not be applied. Okay? However, sometimes if your transaction is very long, if this transaction is very long, you can checkpoint. Checkpoint means it's a partial commit. So up to this one is committed. Up to this one committed. The reason is that if you have the transaction like the 24 hours running time, all changes somewhere you need to keep as a log. It's huge. So you cannot keep all of this on the memory. Even the persistent storage is too big. So from time to time you can checkpoint. It's a partial commit. Okay, but it's still commit. So once every operation in between is done, then you can commit. That is the reason. When you are using the relational database in your program or using SQL, so you can commit. Then commit means permanently applied. If you do not commit, that means it's not applied yet. What is the difference? Commit or uncommit? The commit data, so not committed yet data. If you commit, other user can access the such a changed data. Other user commit data because it's a permanent apply. If you do not commit yet, it's only available in this transaction. So other user cannot access the data. That's the commit. So you need to always end the database transaction with the commit. However, I never use the commit because many of the DBMS and the database programming support auto-commit. If your program is the successfully end of the program, then automatically commit. Because that's our intention of the program. So it's called auto-commit. That doesn't mean that you don't need a commit. Yes, you still need a commit. The only difference is you may not realize. So also, I never use the begin transaction because many of the database program and the SQL, they support automatically start the transaction. Begin transaction is automatically. When you start your database program, when you start your SQL, MySQL, they automatically start the begin transaction. Also, if you commit, then automatically followed by begin another transaction. Like that. So this is the transaction management. Then, why I explained such a transaction management so far? Because I'd like to explain about the consistency. So we learned a lot. The database, relational database is a consistency. It provides a consistency. Similar one is concurrency. Concurrent and the consistency are not the same. Concurrent means the multiple users are running same time, concurrently run. So they are different. So we are talking about the consistency. So, do you remember what is the definition of the consistency? Consistent database is, if you take a look at your database textbook, consistence means it's a certain state, database state to another state. So one state to another state. Then at the time we are saying that this database is consistent. Consistency. Then what other state? We use a lot the name of a state in computer science. Sometimes it's stateful or stateless and something state. So what is a state? Especially in terms of computer science. State. Right? We use a lot state. So what is the meaning of a state? And the stateless or stateful. And state, what is a state? In computer science, state means information or data. Not just the information, not just data, remembered. In other words, store the data. So, which means we are able to read such information, read such data. So, especially in database state, when we talk about the database state, there are two important information. Do you remember that? What are the most important information in database? So what are the DB state? One is schema. Schema is from the database design. So we spend a lot of time to create the schema, database schema. Employee has the social security number, employee ID, and name, e-name, and so on. So this is the database schema. So we can create the database schema like this. EID, SSN, e-name, DNO, address. So this is a schema. Plus, database state means schema and anyone? Instances. So instances means what? Data. What row? For example, EID is 111, social security number 1, 2, 3, 4, 5, 6, 7, 8, 9. The e-name is read and the DNO is 1, address is Bridgeport. And the 112, the this and the name is Patel and the DNO is 2 and the Bridgeport. Like this. If you have such a number of instances with the schema, that's everything of the relational database, right? So, if you have this one, this is called the database state. Then, what are the database consistency? Database consistency means when you, so first you have such a one state, database state, that if you apply the insert, database operation, insert. So new data will be inserted. Like this. So same schema and the 111, 112, 113 is inserted. Okay? So 987 blah 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 and John DNO is 3 and it's a Tremor. This is another database state. If we guarantee one database state to another database state after we applying the database operation. If we guarantee this, then we are saying database is consistent. So this is called the consistency and this is the consistent, the database. Then, is it important or it's not important in our database? For example, this insert transaction. It can be one operation, it can be one transaction. So, this transaction is transfer the money. If database is not consistent, your transaction may be applied, may not be applied. We cannot guarantee if your database is not consistent. So we want the consistent database. Because of the relational database management system. So RDB, or the relational database the management system, born 1969 and 1970. Dr. E.F. Code and his colleague proposed this modeling, then it's almost 50 years ago. Okay? But still being used. It's very popular, and as I show you at the beginning of this semester, still more than the 50% market share. And Oracle is the top company, as you know. The Oracle tried to acquire TikTok. It's one of the biggest Chinese social network, the app, the company, and then they try to acquire. Actually, the CEO of Oracle, Larry, is a big fan of the Trump. So I think that may affect the deal. So, but anyway, still the relational database is the top market share, the database management system. Why? Because it's really, really high consistency. We can guarantee, especially online transaction processing like the banking system and the HR system or the enterprise ERP solution like the SaaS, and as I said, HANA. So they are using the relational database because of high consistency. So it looks like good, right? Then how can you keep such a consistency? We can lawfully so we are going to use a transaction management, such a transaction management to keep the consistency. However, the consistency is not easy. It's a very, very expensive. Okay? For example, one of the way. This is just one example of the way to keep the consistency in the relational database management system. Let me give the small example. So this is the memory. It's a buffer in the database management system. So buffer usually represented by such a grid style. It's the number of buffer. So each buffer size is usually always it's a block size, database block size. A block means what? In database block means it's a database I/O unit. So when you read the data from the persistent storage, so we have the A equal right now is 1. So let's run this is our database. So this is our database. So let's run the update A to 2. I know this is not the correct SQL, but let's say that this is a SQL to update. This is one transaction. The implicit tree, there is a begin transaction. Okay, so when you run the SQL, it's not update right away. This is 2. No, you cannot do that. Inside, any update, change, first you need to read the data. Read data A. So, first, your DBMS look up the buffer. Whether there exists A or not. There's no A. Okay? What happened? You need to, so, this one is called the buffer miss or cache miss. So missing. The ratio of the miss is also very important to judge the performance of the database. Usually 99% is from the buffer. Less than 1% is a buffer miss. Less than 1%. Which means whenever you read the data from your database, 99 point something is from the buffer. Only less than 1% from the hard disk side. So you need to copy this data into somewhere buffer. It's 1. Right now it's 1. So inside, read A. Then we need to write the A to like this. So I update this. By the way, no, you cannot do that. Why? Still, it's not end yet. It's not end transaction yet. Okay? What if? This one is terminate, abort in the middle. all or nothing until end transaction. It should go back. We need to keep this data. Also, what if another transaction would like to read A? For example, select the A. If you hold this the data, you can this other transaction cannot read the data. It's not fair. So I want to just read the data. So it's a lot. So we are going to copy. There are many different ways. This is a multi-version concurrency control, the consistency. So let's say the 1 to 2. This is before A. This is after A. It's still 1. So in case other transaction would like to read the data, it can read this, the before A. Okay, then everything looks good, so we are going to commit. Here. Commit, which means end transaction. So what happened here? So this one will be permanently applied because it's a commit. Then try update this. No, not yet. It's still 1. Then this one is 2. Try remove this before image. Not yet. 1. It may happen even though you commit this transaction 2, still read the data. It's not done yet. So even though commit, even though it's a permanent apply, so it's still 2, still 1. Then each transaction can have their own database state. Right? So this one has database state, schema, and the data. This one has a database state, okay, schema, and the data. It's even before image. At that time, we can say this is a consistent. Database is consistent. There are a lot of things we need to consider. Transaction management, and then the buffer management, and here is also default writing. Even though commit is not applied the hardware, the permanent storage. Later, from time to time, when the system is idle, then it's right. Think about the USB hard disk drive. So USB stick. Sometimes I update the write down and the copy and paste and then pull out your USB. You may lose updated file. Why? Because any operating system, any computer system write the data where? Memory. Always memory. Then this will be synchronized later. Default writing is very, very popular. The most of the system use the default writing. So if you pull out your USB stick before writing, you may lose your data. Same thing in the database system. Even though commit, so it's not updated. Later it will be. Okay. Then what if this one is commit, but it's not applied to the permanent storage yet. But this one is system is unplugged. Somebody unplugged the system. This is a memory buffer. So you may lose this data. But it's still 1, even though coming. So we cannot believe, we cannot guarantee the database consistency. This one is called unrobust. It's not durable system. We need to make the durable, reliable system. Commit is a permanent apply. But because of default writing, we may lose data. So because of that, we have the log file. So when we commit the transaction, log file has the information about A is right now 2. It's always in the permanent storage. So later, when we start up the system, we need to check the log file and this one. A is supposed to be 2, but this 1. We need to redo operation. So read comes here. So read provide the durable system for this. Durable system. So let me summarize. So I spent almost 40 minutes. Let me summarize. This is the most important part to understand today's lecture chapter. First, we are using database use transaction. So transaction, in this transaction management, there are several characteristics. One is automaticity. Transaction is all or nothing. Begin transaction and end transaction. Automaticity. Atomic transaction. It's the atomic, the characteristic. Then, also, transaction, database transaction is consistent. Consistent. Then, when you see the transaction, transaction 2 cannot see the update until commit. Okay? Only before image you can see. Right? But if commit, then new transaction can read the data. But also transaction 2, even though it's a commit but it's still running, then before image is read. Which means each transaction is isolated. Isolated the characteristic. You cannot touch in the middle of transaction because it's atomic and isolated. And the last one is durability. Durable means if commit, it should be commit permanently. So because of the default writing, we may lose some updated committed data from the memory, but using such a log data and redo operation, we can instantly recover the system. Then it's a durable. So this is called the ACID, the main characteristic of relational database transaction. Very strong, the characteristic. Because of this, actually, company use the relational database as a database storage system. Okay, so this is called the ACID, the transaction. Okay. Then let's back to our lecture. So you guys can understand what is the relational database transaction and their characteristic ACID. Okay, based on that. So, the traditional database system has ACID characteristic. So ACID, I already explained. So A means atomicity. So all or nothing. Transaction is atomic, the unit of the transaction. It has a set of operation, but it's still atomic. The consistency is a database is always a valid state, one state to another state. So that is a consistency. Third one, isolation. As you can see, the example of the two transactions, you cannot read the data another transaction until commit. After commit, you are able to read. So this is isolation. And also durability means, so once commit, it should be permanently applied. So this is a very strong, very popular characteristic of the relational database transaction. It's not only for the relational database transaction, it can be used in many computer systems and applications, but relational database use this ACID, the model, the characteristic of the transaction. Benefit, we can believe the data. However, problem is, as you can see, so to keep such a ACID, the characteristic, we need to do what? A lot of things. Okay, we need to use the transaction. We need to do the buffer management, and there are a lot of things. It's kind of overhead. So when we deal with big data, huge amount of data, it will be slow. Because of this, I mentioned several times the relational database is good, but it can manage up to petabyte size level, petabyte. If you have more than that, higher, bigger than that, it's too much overhead, so you cannot get the benefit of the using database management system. So, when we have such a huge amount of data or the big data, what will be the solution? So we can use the distributed system using cluster. Divide and conquer, why not? To have the more and more computer like that. Can we keep the same ACID characteristic in the data for such a distributed database? Unfortunately not. So we defined such the property of the distributed system in terms of the three parts. One is the consistency. So database should be consistent. So which means when we have the multiple node, this is one database, another one, number of them. So each and every node, all nodes have the up-to-date the data, so state, so that is so consistent. Another, the expectation of the distributed system is availability. So whenever we request the data, like the read the data, then should be available, even though partial tolerance, which means part of your distributed system is not accessible, or something problem, or failure. It should be okay. That is called the partition tolerance. So there are three properties we may expect from the distributed system: consistent and available and partial tolerable. So consistency, availability, and partition tolerance. So this the characteristic is called CAP, C-A-P. Then think about, can we have all three properties in our distributed system or NoSQL database? That's the question of today's lecture. Okay? So can we keep or not? If not, what will be the solution? So then what about the relational database? So think about the relational database. Relational database is consistent, right? So this is good. Relational database available. Always you are able to access the data. It's available. But not partition tolerance. Right? We cannot have the partition, distributed database. Distributed database system at that time is not consistent or not available, especially not consistent. So our relational database system is not partially tolerable. So what about the other NoSQL database? So first answer. Answer is we cannot have all three properties in our NoSQL database. So that is called the CAP theorem. So we can prove that, but we are going to see the high level, the easy solution of easy proof of such a CAP theorem today. So answer, first, we cannot have all three. Later, at the end of today's class, still company like the Google and Amazon, and the Oracle, they'd like to even address such a problem of the CAP theorem also. which is called the new SQL. I introduced what is a new SQL, but the new SQL database actually try to keep all these three. It's ideal. CAP is ideal, but practically not, theoretically not possible, but practically we'd like to have the all three property in our the NoSQL database. Okay. So most of NoSQL database pursue instead of ACID, it's basically available soft state eventual consistency. Let's see first the basically. So available means basically available, not all the time available. Momentarily it may be stopped. Okay, you cannot get the response. Basically, but it's available. It's different from fully available. It's different. Basically available. What about the state? The consistency. Consistency is eventually consistent. It's not the right after commit. Eventually, because it supports the soft state. Soft state means that it's not changing 1 to 2 database state. Instead, eventually. So it's called the soft state. So eventually, the consistency. So that's the idea. So it's called the base transaction. So which means simply relaxed ACID. ACID is too strict to keep the very strict, very strong consistency. But our NoSQL database is loose, release, okay, weak consistency. So if you cannot imagine what is the eventual consistency, what is the weak consistency, let me give the example of the Facebook. I'm using this example a lot. So when you access the Facebook, probably Facebook has the distributed system, right? It's not one centralized. So this is the America. So they have the server for the America. This is the Asia server. This is the Africa. This is India, and this is Europe. So tomorrow is the biggest holiday in Asian country, which is called the Full Moon Day, and it's like the Asian country. The lunar calendar is a Thanksgiving Day to celebrate the harvest and so on. So it starts. My country has a week long the holiday from tomorrow. Right now, I think that in Korean time, so it's already holiday start. So the happy Full Moon Day. Send a message, post a message to my Facebook account. So then they call me. So I sent posted a message, but I cannot see this message. Why? Because this message on the Asian, possibly Asian server in Asia. It's not synchronized to the server in North America. So which means it's not consistent. However, eventually this will be synchronized, so it's a happy Full Moon Day. Here, this is called the eventually the consistent. But it's really hard state and strong consistent. When you write this one, you will synchronize. But it takes a time because it's network, distributed system. During that time, system will not be available. You cannot see the data. Okay? So that's because of the cap there. So database system, distributed database system, and NoSQL database use such a relaxed base. The transaction is basically available soft state eventual consistency. In short, it's a base the transaction. We sacrifice mostly the consistency or isolation, which means even though it's not transaction is not committed, it's available. Think about it. Even though the data is not, the post message is not seen yet, it takes 1 or 2 minutes. Are you going to sue the Facebook? Probably not. So you can wait 1 or 2 minutes. It's not critical. It's not the case to sue the Supreme Court or whatever. However, if this is a banking transaction or the bidding system, this is really hard consistency is really critical. So if your bidding is not accepted, then you may sue the company. So some of the system nowadays, like the social media, social network company, or such a thing, we can sacrifice the consistency. Not 100%, but little bit sacrifice. Okay. So then, what will be among the ACID, the concept from the ACID? What will be the important part? System should be available. Like if Facebook is not respond to anything, it will be the prime time news, right? Because availability is more important than the consistency in such a data. Okay. So most of the NoSQL database or distributed database system provide the base rather than ACID. Okay. So this is the comparison between the ACID and versus the base, the characteristic. So ACID keep the high consistency, very strong consistency as well as isolation. I explained about the isolation, okay? But on the other hand, the base is weak or the lacks consistency. Okay? Eventually, it's a soft state. And availability is more important. Availability. And also this one much easier to implement. Comparing to the ACID, I already explained several techniques to keep the consistency as well as the isolation. But that's not all of them. There are much more. Even I actually explained very high level. It's much more complicated. You need to have something transaction scheduling and so on. But if you have such a very strong or the very complicated implementation, like the distributed system, you cannot actually manage. So base is much more simpler and also faster. Fast response time is important in the Facebook. Okay, so that is a base. So then, what is the cap theorem? Cap theorem actually among the 3 characteristics of the distributed system. One more time. Such a 3 is consistency and availability and the partial tolerance. Consistency means it's one state to another state. We guarantee the data. That is consistency. Available means it's the system, distributed system, especially in our case, the database system should be available. In case part of the system is not working still, your entire system is working. So that is the partial tolerance. So among this, cap theorem means only 2 of them are possible, which means C and A, consistency plus availability, C plus A, or the A and P, A plus P, or C and P, C plus P. Not all these 3. Okay. I gave the example of what about the update from H and to J. So when you synchronize the disk, okay, during that time your system should be stopped and then synchronize. So it's not available. Or if you make them available, in case one of them is not working, okay, you cannot recover totally. So that is the example of the counterexample of the CAP, or the cap theorem. So this cap theorem was proposed by the UC Berkeley, the Professor Eric the Brewer, and he published a paper in 2000. So then only at most the two characteristics of the distributed system can be satisfied, not all three. Okay, then you can find more information about such a cap theorem and from the link, and also you can find the paper to prove it. So we will see the very high level of this cap theorem. Okay. So there are three characteristics of property of the distributed system. One, NoSQL database, consistency, availability, and partition tolerance. I already explained about each of them, so then you guys can easily understand what of each the characteristic of the NoSQL database. First, consistency. So think about the relational database is focused on very high, strict consistency. On the other hand, the other NoSQL database that we are going to discuss and learn are the eventually relaxed consistency. Availability data should be available all the time, and the partial tolerance is the data is partition, it's distributed. Then if part of the system is not available, it's not accessible, still entire system should be working. Okay, so let's have the 10-minute break. So we are going to continue 7:20. Okay, so we will have the properties in the distributed system, specifically the NoSQL database. Then finally, we have seen in the first part we have seen the what is the cap, the consistency, availability, and the partial tolerance. So cap theorem means we cannot achieve all three properties of the NoSQL database. Instead, at most we can have the only two the part as a characteristic of the NoSQL database or distributed system. We are going to see more details in the second half of today's class. Before that, I'd like to remind you, so second piece of the task 1, the project is due on this Friday and also available to submit until the Monday next week. So please rate your selected database research the paper and prepare for the 5-minute presentation. The next week, the 6 p.m., we are going to have the very short presentation for each selected database. So if you are not available during the class, you need to submit the less than 5 minutes the video on Canvas. Then I'm going to turn on the video first, then each student will have the presentation. If you are going to attend the Zoom meeting and present during the Zoom meeting, you don't have to submit the presentation, the video. Only the PPT file is enough. So please be ready for the presentation, 5-minute presentation next week regarding to your research on your selected NoSQL database. Also, if you can find any missing or wrong information about your selected database, I updated on the homepage of Canvas, our course, the page. So just let me know, then I'm going to update it. Okay. So if you see the paper mentioned here, so you can find the official proof of the cap theorem, but in this class we are going to see the very high level, the simple proof of the cap theorem. So for example, there is a system. Suppose that there is a system, it's a consistent and a variable. That is a fixed one, then we will check the partition. So if we have a partition like that, partition means the data is not centralized. So you can have the data A or data B. So it's a consistent and a variable, which means so when a user accesses any of A or B, it should be the same, synchronized, consistent, and also same time available. Then, however, if data is partitioned, it doesn't make sense, right? So they should be synchronized. So because of that, we cannot have the partition when the system is already consistent and available. Also, another example is what if the system is available and partition like this one? It's A and B. So can we keep the consistency? So this is a simple example. So for example, if the data is updated 1, so this is available and partition. So but the while this one is synchronized to the here, so it's not available so during that time. Okay, so you need to lock and stop the system until such a synchronization is fixed, finished. So because it's a partition, but it's not. So data is here, so then so it's not synchronized. So oops. Let me point here. Okay, so in case the system is available and partition, you cannot keep the consistent. That is the cap theorem. Another case is the database is consistent, so they are consistent, and also partition, so which means here, so it's a partition, the A and B, and then they are consistent, so which means they should be synchronized every time. Then when the client accesses the data, they should be the same. But to do that, we need to synchronize, which means in case during the time during the synchronization, if the other user access the data, it should be locked until such a synchronization is finished. Okay. So that is the cap theorem. So in terms of cap theorem, let's take a look at what kind of the system NoSQL database belongs to the cases. So first, we are going to see the consistency plus availability, which means we can keep the data is consistent and also make it available, but give up the partition, which means it's a centralized one. What are the examples of such a thing? Relational database. Relational database, we cannot partition. You may heard the partition table. That partition table does not mean the server system is partitioned. Instead, one table is divided. Okay. So then, how can we keep such a consistency? So we can have we have seen the example of such a transaction management before. Plus, there are several other things. So for example, the two-page commit. Two-page commit is when we commit the data, because one transaction may have the multiple data update and read. So to acquire the lock, there are two pages. So getting the lock, getting the lock, getting the lock, Then the release lock, release lock, release lock. So we have learned about the two-phase commit. And also cache management. We have seen the example of the multiple version, the multi-version, the buffer management. In other words, it's cache validation protocol. Okay. So example is relational. The typical relational database has a consistency as well as availability. What about the consistency plus partition, which means sometimes the system may not be available because we need to keep the consistency along the different partition. So we give up the availability. Okay? So at that time we need to lock. It's a pessimistic lock. Pessimistic lock means it's a falsely lock. Okay? So during that time, locking time, we cannot access the system. Okay? Most of the distributed database has such a consistency plus partition. They give up the availability. So because of that characteristic, such a distributed database system need the different data model that doesn't require a lot of consistency. So they divide the table along the different partition, or they divide one table by column along the table like that. So distributed database system uses such a consistency and partition. However, because of this characteristic, distributed database system has not been used a lot in the market because it give up the availability. Okay. The last one is availability plus partition. So which means we give up the consistency, not entirely give up. So as we have seen at the beginning, the eventually consistent. So it takes a time to synchronize, make the consistency, but it's not strict the consistency. Okay. So it's optimistic concurrency means it's allowed to access the data, but they may see the different the value. Okay. Then the example is many of the NoSQL database support this availability and partition, giving up or the relaxed consistency. And the web caching and many of the distributed systems nowadays use this availability plus partition. So this slide shows the example of such a system more detailed. So this is the consistency part. This is the availability part. This is a partition part. If the system, distributed system, in our case, so in the class is the NoSQL database. If the system keeps the C and A, consistency and availability, the relational database is a CA model. And some other example, but they are not much used. But what about the C and P? Is consistent and partition, but may lose the availability. So like the Google Big Table or the MongoDB and such a database Memcache. I think the one student may choose the Memcache at this time, not sure. And also HBase. HBase used such the C and P. Okay. So many of the NoSQL database actually support A and P. They may not entirely give up. It's eventually consistent. DynamoDB, Cassandra, the SimpleDB, CouchDB, React, and Birdmode. Most of them are selected as a project, the NoSQL database. So we will see in the presentation. So you can discuss more details. So my selected database support the AP model because this one, this has such a characteristic. There are different types of the NoSQL database. So we will see. This is in terms of data model. This is in terms of data model that we will see such a example. You can categorize now nowadays actually it's a multi-model, but we can basically categorize the NoSQL database into 4 types. The first one is a key value, second is a documented-based NoSQL database, third one is column-based, the fourth one is graph-based database. Okay, we will see one by one more details. So first key value is during the head class, oh by the way, so GA, the MC uploaded the exercise library. So after the class, please watch the video. It takes 20 to 25 minutes regarding to the map reduce programming. So please go ahead and follow the instruction. Then submit the proof of the exercise lab by taking the capture image, then upload to the canvas. Okay. Link is the same as the last one that I sent. It's the course playlist. Okay, so key value. During the Hadoop, so we talk about what is a key value. Is if you forget about the relational database model, it's easy to understand what is a key and what is a value. We are going to consider the data as a value, and each data has their key. This key doesn't have to be the unique. Instead, the key will be useful to compare with other. So we can sort the data using key. We can compare the data using key. We can do something, the job, using the key. That is a key. Key doesn't have to be primary key or the unique key or the something. So just a key. Okay? So then the other data will be value. So we can use such a key value concept for the map reduce programming. So many of the NoSQL database, or distributed database, the NoSQL database use such a key value model. Example is the Amazon Dynamo DB and also the many others. So in key value format, they support another characteristic of the NoSQL database. Some of the NoSQL database provide a programming interface, like the SQL. You can use the SQL to access the data in NoSQL database. However, keep in mind, SQL, structured query language, is only for the actually relational database model. But because it's easy to use, easy to learn, many people love to use the SQL. And sometimes NoSQL database, even that is not relational database model, they use the SQL interface. But most of the NoSQL databases support API access. The library, application programming library interface, the model. Like the most popular one is the get key. Using key, you can get the value. Put, insert, you can create the instance using key and value. Delete the instance using delete key, like that. Okay. So key value is the most popular one. It's very fast because of simplicity. And also it's scalable. So you can add the node. Okay. Then like the Hadoop HDFS is a very high scalability, linearly increase the scalability. And the data model is simple because it's a key and value. In other words, that can be the problem. You cannot model very complicated, complex the data model. Also, key value support eventual consistency. We do not insist strict consistency in the key value model. Also, fault tolerance because it's basically distributed. Then we can in case of a partial failure, the entire system should be tolerable. It's working. Okay? However, key value doesn't support a very complex data model, unlike the relational database model. Okay? These are the example of the key value model, the NoSQL database. Some of you guys already select the database like the SimpleDB, RedisDB, DynamoDB, Vault the DB, or see DynamoDB in the classroom. Here the database the student already selected as a project topic, so we will see the characteristics such a database during the presentation. That is one of the purpose of the student presentation, to know about the other NoSQL databases. The next type of the NoSQL database is the document database. First, we need to understand what is a document. So when we talk about the document as a data or the database, a document means it's not just a PDF file or the text file, text data like the report, MS Word. Instead, the document means, so document include mostly markup language. Like the typical example of such a document are the HTML, hypertext markup language. Think about the Google or Yahoo. So when they build a search engine, first they need the data. What are the data? Their data type is a file. Specifically, mostly, not always, but mostly, is an HTML file. Then they wanna build an index because they have too many data to search. It's too many. They create the index. What kind of index? Using keyword. It's an inverted index. But how can we consider? How can we make the database system? It's based on documents. So when we are saying the document database, document-based database, document does not mean the MS Word or the PDF file. Instead, document means kind of markup language, including the HTML file or XML file is another example. Nowadays, JSON file is most popular, the data type used in the document. JSON file means it's a JavaScript object notation. File is a standardized. It's in the Java the script, the JS. They sometimes need to communicate, send the data, receive the data. They need the standard, the protocol. So JSON was developed, proposed, and used for the data transfer between the JavaScript. But it has been used a lot in the data analytics and many of the data form. Okay, because if you, let's go back to the this one. So this is a JSON file, the JavaScript, the object notation. So let me briefly introduce what is the JSON file, then go back to the NoSQL database, the type. Okay, so what is the JSON file? JSON file is to exchange the data in the JavaScript. So they have the standard. So it's in the Web 2.0 application is adapted. So if you see the bottom here, like this, so this is the type of the JSON file. Okay, so let's take a look at the more details of that here. So this is an example of the JSON file. As you can see, so it's a very similar as well. In Python programming, it's a dictionary. It's a key and value, right? So if you have the list of data, then with the key. So it's very similar as a dictionary. So nowadays, the data science, data analytics application, they are using the JSON format as a type of their data. So JSON is not only for the JavaScript, the transfer. Nowadays, it's used a lot in many of the applications. So if you are using this JSON file as the data instance, this is called the document database. So document database uses a JSON file as a data object. So there, the normal form is very simple. Okay, it's almost the same as the dictionary type. So you guys can easily use. So in the Python or the Java, the languages, the parser is most of the program languages support the parser, as a library. So you can easily import the JSON file and export the data to the JSON format. Okay. Then go back to our NoSQL database. Okay. So this is a document-based database based on the JSON. So this is an example of the MongoDB document. Okay, it has the name of the file, the data item, and address is like that. Even just like the JSON format, we can include inside the array like this. So example of such a document-based database is MongoDB and the Couchbase, the database. So MongoDB is one of the most popular NoSQL database nowadays because it's basically support the document as a data object, and it supports the object-based structure, the data model also. And also it's high scalable, so it's almost one of the most popular, the NoSQL database. The next one is column-based. So far we have the key value, and the second thing is the document. So document, and third one is the column-based. What are the column-based? To understand what is the column-based database, we need to think about the relational database program. So next week we will see the more details about the relational database in terms of a NoSQL perspective. However, before that, we already know the relational database has based on the relation. What is a relation? It's the name of the attribute. So ID and name and this one. Then we are going to create a lot instance, insert, like this. Which means if you compare number of attributes, number of the data, which one is bigger? Obviously, number of data is much bigger than the number of columns. However, when Dr. E.F. Code proposed relational model, he defined the relation table as two ways. One is a group of columns or group of data. However, after that, like the Oracle, MySQL, most of the relational database focus on the first a small number of attribute designs, and then insert many data. So our goal is to find the specific data. It's more like the data-driven, the row-based, or the data-driven, the table relational model approach. Why? Because of one of the characteristics of the relational model is relational model really hate the duplicate data. So how to address that? So we are going to apply normalization form. Normalization means it's a chart, segment to segment. So we have a limited, less number of columns compared to the number of data. So our focus is the data row. Why not have the many columns and less the data? Think about, for example, the sensor. So we have a new sensor like this one. So this one is like based on the IoT, Internet of Things. Then it has something temperature, humidity sensor. Then we build millions of them from the airplane deploy. Then we'd like to check so we have 1 million of column. Sensor 1, sensor 2, sensor 3, and time. Every minute we collect the data. How many column? 1 million. How many data? So once a minute, so 60 times 24 a day, like that. We have the many column. So our goal is to find the specific column. So query processing, query optimization, we focus on finding the column like that. So column based is also another approach, column-oriented database. And also, because of this characteristic, it's not easy to change the attribute. In other words, it's not easy to modify, revise the model. Because our modeling focuses on this attribute. So once you decide the column, will not be changing. What if we have the new data that has a new attribute? Phone number was not here, but the phone number. You need to change everything. So that is the limitation of relational database. But NoSQL database, we don't want to restrict such the data model. So depending on the data, it may have the column, it may not have the column. So you can create the column based on the data. This is called the column based. Think about the HTML page. When you download the HTML page, some of the HTML page has a title. Sometimes not. Some of the HTML page has the professor name column, but the others are not. Depending on the data HTML file, it may have the column or not, So it should be flexible. So NoSQL databases support such the model, which is called the column based. Column based means column is very, very flexible. Even sometimes it's called the semi-structured or unstructured data. So when we are talking about unstructured data model, unstructured data means it's a flexible for the column. Also sometimes it's suddenly forgot the name of it. Okay, if I remember. Oh, then instead we provide a column family, group of columns, like the profile. Under the profile, you can create a certain column, like the age, or the gender, or the other information based on that. So you can just specify the group or the type of column. That is the column-based database. Google Big Table used such a column-based, and also H-based, Hadoop database that we are going to see the first. So which is the column-based database. So these are the example of the column-based. So big table, H-based, hypertable. Cassandra, we will see the Cassandra also is a column-based. The next one is the graph-based. What is a graph? Graph is basically a number of edges and number of the vertex. Edge means is entity. Then one of the characteristics of the graph data structure is you can use the relationship between the node. E is my mistake. The B is a vertex, is called the node. Then the edge is the relationship between the node 1 and node 2, if they are connected. So this is called the graph, the data structure. So nowadays we have more and more the graph data structure. For example, social network, Facebook, Tweet, the TikTok, all of them are based on the graph. And also relationship, like this movie is supported by this. So one of the main characteristics of the graph data structure is it can represent relationship between the entity and vertex and data. So unfortunately, it's not simple to store this data into the relational model. You can do that, or even you can use column based, but you may use such a characteristic. Characteristic means the edge represents the relationship between the node. So new type of the NoSQL database support such a graph structure. For example, Neo4j is the most popular one, and we have FlopDB and so on. So if you are interested in more about such the NoSQL database model, you can read such a paper. But first thing is please research on your selected database. Then you will learn more. From the CAP theorem, so what types of the NoSQL model my database is, like that. Okay. So that's the end of today's class. Any questions? If you have any questions, so please unmute by yourself, or you can use the chatting box. Okay, if you do not have any question, let me stop here. Then after the class, we have the 30 more minutes. During that time, please complete your exercise lab 3. So regarding to the map reduce programming, you can watch the uploaded video by the J. Bamsi. He uploaded the instructional video. You can follow that instruction to complete the exercise lab 3. So the video is available at the playlist that I sent last week. So please go back to the last message and click the link. Then you can watch the video. Okay, one more time, by next week, you need to complete the page 2 of the test 1. So writing research on your selected database, write the paper and submit it, and also be ready for the 5-minute presentation. If you are attending the live Zoom meeting, so you can just use upload the PPT file, then present within 5 minutes. Otherwise, if you cannot attend the Zoom meeting, you need to submit the recorded video to the Canvas. Then I'm going to turn on at the beginning of next class. If you are coming to the classroom, definitely fine, so you can present in front. Okay, so thanks so much for your attending, and then stay safe. And I heard that more and more confirmed cases around the Canvas and the New York area. So please be healthy and stay safe. We will see you next week. Thanks so much.